All right, so we're going to go ahead and get started on lesson 2.5 here. We're actually going to go ahead and get started with the warm-up, as a warm-up actually shows us how the new method we're seeing today, which is grouping, works. So in this case, I want to go ahead and factor the expression 5x squared plus a 10x plus 2x plus 4. And in this case, the way we're going to go ahead and factor this out is that we're actually going to be creating two different groups. The first group is actually going to have our leading coefficient and one of the x terms, and the second group is going to have the other x term plus our constant. So in this case, I'm going to go ahead and group this one along with this one here. So once we group them, we actually want to go ahead and find factors of within each of the groups. And then from there, we'll go ahead and do another factor. So starting off in this case, we do have the 5x squared plus a 10x plus a 2x plus 4. If we take a look at the first group here, the 5x squared plus a 10x, we have to find out what they have in common. In this case, both of them are factors of 5 or multiples of 5, and they both have an x. So in this case, I could actually factor out a 5x. Now, if I factor out a 5x here, then I should have another expression inside. So factoring out a 5x from a 5x squared actually leaves me with an x. Factoring out a 5x from a 10x actually leaves me with the positive 2. Now let's go ahead and move on to the next one, and we have a 2x plus a 4. The GCF for the factor that they have in common is actually a positive 2. So I'm going to go ahead and factor out a positive 2. And in this case, if I factor out a 2 from a 2x, that's going to be an x. And if I factor out a 2 from a 4, that's going to be a 2. So this is our first factor. Now, from here, we want to go ahead and factor one more time, and we actually have to see what they have in common. If we take a close look here, they actually have in common the x plus 2. So what we're doing in this case is that we're actually going to go ahead and factor the x plus 2, and then whatever was left, the GCF from each of those is actually going to form another binomial. So in this case, we would have x plus 2. That actually becomes a 1 because we're factoring it, and then the initial factors become another binomial. So this here would be our answer. That would be our answer. So in this case, this is how grouping works, and we're going to go ahead and show 3 examples on factoring quadratics using the diamond method plus grouping. So starting off here, guys, we have the expression of 2x squared minus 7x plus 6. And I want to go ahead and factor it using grouping. So starting off, I do want to go ahead and check for any GCFs. Any numbers in common between the 2, the negative 7, and the 6. In this case, they don't have any numbers in common, so I'm going to go ahead and move on to identifying A, B, and C. So A in this case, B, and C. So starting off, A in this case represents our leading coefficient, which is a 2. B represents the x coefficient, which is negative 7, and C represents the constant, which is 6. Now, from here, we want to go ahead and build our diamond, and the diamond works the same way. We have A times a C, and then we have a B. So in this case, A times C is actually going to give us a 12, and B is going to give us a negative 7. So we're looking for two factors that multiply to a 12 and add up to a negative 7. In this case, those factors would be negative 4 and negative 3. Now, in this case, we're going to go ahead and take a look at our A value. Our A here is not a 1. Remember in the previous lesson, we talked about A being a 1. If it was 1, then we were done factoring. In this case, it's not a 1, so then we're going to go ahead and move on to grouping. Now, in this case, grouping, how it is that we just have to rewrite the original expression, but instead of writing the negative 7, which is our middle term, we're actually going to go ahead and replace it with our factors that we just found. So this actually goes on to being, or let me actually write it on top. This actually goes from here. It actually becomes a 2x squared minus a 4x minus a 3x plus a 6. Once again, we replaced the negative 7x with this here. If I combine this here, I will be getting the negative 7x. So from here, let's go ahead and do grouping. Let's go ahead and group these. And let me actually just move this a bit, because whenever we do have a negative, there is still an addition sign in between them. So I will be grouping these, and I'll just put a plus sign in between them. So from here, let's go ahead and factor. The first group, we have a 2x squared minus a 4x. And the numbers they have in common in this case would be a 2x. If I factor out a 2x from a 2x squared, I'm left with an x. And if I factor a 2x from a negative 4x, I'm left with a negative 2. Now, let's go ahead and move on to the next one. We have a negative 3x plus a 6. Once again, this is our first term, and we do have a negative, so we'll be factoring out a negative number here. So negative 3x and a 6, what they have in common is negative 3. So I will be factoring out that negative 3. If I have a negative 3x and I factor out a negative 3, I'm left with the x. And if I have a 6 and I factor out a negative 3, that actually becomes negative 2. From here, we see what they have in common, and they both have x minus 2 in common. So that's going to become one binomial. And then the 2x minus 3 is going to become our second binomial. So we have x minus a 2. And then we have 2x minus a 3. And this here is our answer. That is our answer. All right, comments or questions here, guys? Once again, this is grouping. This here is grouping. Now, I do want to go ahead and show a different method here. Let me just move this down. I want to go ahead and show a different method for us here. Let me just move this down. All right. Now, the different method in this case, it's actually a less process for us to work here. And it's known as the Jaime Escalante method. Jaime Escalante method, I'm not sure if you guys have heard it or if you know who Jaime Escalante is. But this is a method that was named after him. So let's go ahead and see how it works. So in this case, with the Jaime Escalante method, I'm going to go ahead and do it on the bottom here. Jaime Escalante method. So what it does in this case is we're going to go ahead and actually repeat the same process of identifying A, B, and C. And we're going to go ahead and build our diamond. So starting off here, we had the expression of a 2x squared minus a 7x plus a 6. And we want to go ahead and identify once again A, B, and C. So A, B, and C. In this case, A is a 2, B is a negative 7, C is a 6. So let's go ahead and build our diamond here. And we have A times C on top, and we have B on the bottom. A times C in this case is going to be a 12, B is going to be negative 7. We found these factors to be negative 4 and negative 3. Now here, instead of us actually grouping this expression, we're actually going to be dividing by the leading coefficient. In this case, our leading coefficient is a 2. So each of our factors in this case, I'm going to go ahead and actually divide by a 2x. A 2x divided by a 2x. Once again, the x is for me to create the binomial. The 2 is actually our leading coefficient. And from here, since we're dividing by a leading coefficient here, we want to go ahead and simplify any expressions we can. In this case, I have a negative 4 over a 2x. I could actually simplify that out. And let me just move this here so I could have a bit more space. I want to go ahead and simplify that out. If I simplify it out, that actually becomes a negative 2 and an x. Once again, I am keeping the negative with the number that we started off with. So since the negative 4 started off with the negative, I'm keeping it with the negative 2. In this case, if we look on this side, we can't simplify this out. So the binomials we're going to be working with is this one and this one. Now, once we do that in this case, I'm actually going to go ahead and write our binomials here. We're going to start off with the x, and on top we added the -2. And then the next one would be the 2x minus the 3. And these here are our factors. And if we take a look at the one on top, they are exactly the same thing. So there are two different methods here for us to use. It's really whichever you want to use. This is a grouping. It's a little bit more process, works the same way. And then we have the Jaime Escalante method, which is less work, and it gives us the same answer here. So let's go ahead and move on to the next one. And on this one, I will be showing the diamond method plus grouping. In our next example, I'll go ahead and show the Jaime Escalante method. So on this one, once again, let's check for any GCFs between 6, -5, and -4. And we actually don't have any. So let's go ahead and identify A, B, and C. A in this case is a 6, B is a -5, C is a -4. So let's go ahead and build our diamond here. And we have A times C on top. We have a B on the bottom. A times C in this case is going to give us a -24. B is a -5. So two numbers that multiply to a -24 but add up to a -5 in this case would be the -8 and 3. So from here, I want to go ahead and see if my leading coefficient is 1. In this case, it's not. So we're actually going to go ahead and move on to grouping. So here we're going to go ahead and move on to grouping. Once again, whenever we're grouping, we're replacing the x coefficient, which is the middle term of the original expression, with the factors we just found. So that would be 6x squared minus an 8x plus a 3x minus 4. And in this case, guys, whenever you're rewriting these terms here, the x coefficients, there's no correct order for us to do it. You could actually factor any way. I could put the 3x here and the -8 there. It's still going to be the same thing. So let's go ahead and group them here, grouping the first one and then grouping the second one. So starting off, any common factors between 6x squared and a -8x, they both have in common a 2 and an x. So I'm going to go ahead and factor out a 2x. So this is a 2x on the bottom. And if I factor a 2x from a 6x squared, I'm actually left with 3x. If I factor out a 2x from a -8x, it's going to be a -4. Now in our second group here, we have a 3x minus a 4. They actually have nothing in common but a 1. So because they do have a 1 in common, I'm still going to go ahead and factor that out. So I'm actually going to factor out a +1. So once again, even if they just have a 1 in common, I still need to factor it out. So from here, the binomial stays the same. Now, we have to see what they have in common. Once again, if we take a look at this here, they both have a 3x minus a 4 in common. So that's going to be our first binomial, 3x minus a 4. And our second binomial in this case is going to be composed of what we just factored, which would be the 2x plus a 1. And this here is our final answer. Once again, if you decide to use the Jaime Escalante method on this here, we should actually be getting the same answer.